Hello everyone. So in this session, we will start with graphs. So before going to graphs, why do you require a graph? Where do I use this graph? Once again, the graph is one of the types of nonlinear data structures where we cannot store in sequential memory. It will be random. So where do you use a graph in day-to-day life? Day-by-day life, wherever we go, we will use maps. So for maps purpose, always we have a nodes and edges. So we have a source, we have destination. We have a source and we have a destination where we want to reach. And then the path to the destination, it's going to be the one map, graph. Likewise, in graph, we have nodes and edges. There are different nodes are there. A, B, C, D, there are nodes are there. And then connection of those nodes are called as an edges. Likewise, in maps, we have source, we have destination, and then between source and destination, we have a path to reach the destination. So that's the one type of real life examples. The other one is your social networks. Your people, the people are nodes. The people are nodes, and the edges are friendships. Once you give friendship request, if they accept, there has been connection has been formed between two people. So once again, a social network is going to be another real life example for the graphs. The other example is the internet website. So the web pages, once you go inside the web pages, we have hyperlinks will be there. So then once you click the hyperlink, it will goes to the some other page. Once again, two nodes and connection has been created. And the other example can be an airline routes, where airports are the nodes and then flights are the edges. The flights are the edges. So why do I need to learn the graph? Because it will solve the real time problems. Okay, the best example is the shortest path, the GPS. Okay, so by having a maps, I'm able to see when can I reach a destination, what are the ways to reach a destination. So it solves real time problem. That's the first useful for of the graphs. The second one can be network flow. So depends on the internet traffic, I can solve the problem, and then I can use for recommendation systems. For example, Netflix or YouTube. Okay, I can by using the graphs, I can recommend the corresponding content for you people. So depends on the how you use the content. Suppose if you start to see more thriller drama, then accordingly the edges will be created for the recommendations were created for the more thriller drama genres to you people. So these are the application of graphs and then real time scenario where we can use the graphs. So in today's session, we will see what are the graph terminologies are there. Likewise, in trees, we have seen different terminologies. So likewise, in graphs also have certain terminologies. So we will see one by one. So now here, a graph is defined as an ordered set V, E. So here we will call vertex and edges. The nodes are called as a vertex, and then the connection between the nodes are called an edges. A simple, uh, you can see here A, B, C, D, E. So these are called vertex. These are called vertex. So V of G is equal to A, B, C, D, E. And then edges, E of graph. The edges of the graph, E of G. Between A and B, we have one edge. So A comma B. Between B and C, we have one edge. So B comma C. Likewise, AD and BD and DE and CE. So this is how we will define a graph. Vertex and edges. So V of G is nothing but vertex of graph. And then E of G is nothing but edges of graph. Where V comma E is nothing but vertex comma edge. How many number of vertexes are there? How many number of edges are there? So a graph can be an directed or an undirected. So it's simple. If you have direction in the graph, that's called directed. If there is no direction, it's an undirected graph. So here graph terminologies. The first one is going to be an adjacent nodes. So adjacent node means what here? If I have connection between the A and B, so for A, the adjacent nodes are B and D. Since I have a connection, the adjacent nodes are B and D. So these are called adjacent nodes. And degree of a node. Okay, that's another terminal called a degree of a node. So the total number of edges containing the node. So degree of a node. So for this A, total number of degrees is going to be total number of edges. Total number of edges. So it's going, we have one edge and then we have another edge. So degree of a node A is 2. Degree of node B is going to be 3 because left side one connection, right side one connection, down side one connection. So 3. So degree of C is going to be 2. E is going to be 2. D is going to be 3. 1, 2 and 3. So see, if there is no connection, it's going to be an isolated node. Isolated node, it will be 0. Degree of node is going to be 0. So that is called an adjacent node and degree of a node. And then regular graph. Regular graph is nothing but each vertex have the same number of neighbors. For example, you can see here, uh, for example, this node have only one neighbor. This node having only one neighbor. And this node having only one neighbor. So that is every node has the same degree. So for this node also degree is 1. This node also degree is 1. Degree is 1. Degree is 1. So whereas here there is no connection. So it's an normally there is no connection. So 0 edges are there. So 0 regular graph. There is only one edge common throughout the graph. That is one regular graph. So you can see here between 3 nodes we have the connector. So this is called two regular graph. So a regular graph means what? It have an each vertex have the same number of edges. That is called regular graph. So these are the different terms which we use in the graph. Path, closed path, simple path, cycle. A path is nothing but suppose in a graph with nodes A, B, C and D, and there will be a path from A to D. A, B, C, D. That is called path. A sequence of nodes where each pair of consecutive nodes connected by an edge. That is a path. And next one is called closed path. So closed path means nothing but cyclic. So we have an A, B, C nodes are there. So A, B, C, and once again it will close the path with the A. That's a closed path. And simple path where all the nodes are distinct, except that the starting and ending node may be the same in the case of a closed simple path. So now here A, B, C is a simple path where all the nodes are distinct. It doesn't need to be all the nodes should be covered. Okay, even A to B is simple path. Even B to C is a simple path. Okay, but ABA is not. It's cyclic. It is a cyclic closed path. So wherever we have a simple path, it doesn't need to be cover all the vertices. It doesn't need to be cover all the vertex should be have two neighbors, nothing like that. A simple edge called a simple path and cycle. A closed simple path of length 3 or more. So whereas here A, B, C, and once again it comes back to the A. A cyclic. It's like a closed path and cyclic. Okay, these are different terms which we have in the graphs. And next one is called an connected graph. Okay, so a connected graph, when will you call as a connected graph? When there is exists a path between any two of its nodes called connected graph. So I will show you example. A simple graph. A simple graph means what? All the nodes are gets connected. All the nodes are gets connected, and then there's a multi-graph. Multi-graph means multiple connections are there. For the same two nodes, we have multiple connections. You can see here one connection, and there is another connection. That is called multi-graph. When we call it as a complete graph means, so when all the nodes are connected with each other, when all the vertices are connected with each other. So this node is connected with the second node and third node and fourth node. Likewise, this node also connected with the first node and third node and fourth node. Likewise this node, likewise this node. So all the nodes are connected with the remaining nodes, that is called an complete graph. Whereas here in the simple graph, there is no connection between the second and 3. So it is not a complete graph. So whenever we find a connection between all the nodes, that is called complete graph. And then a graph with loop. What's a loop? It's once again going back to the same node. Okay, this is a loop. This is a loop. It's going back to the same node. And digraph is nothing but direction graph. Digraph is nothing but a direction graph. So this is called an there are different terms are there in inward and outwards. Okay, you can see here out degree of a node, in degree of a node. Okay, so out degree of a node is going to be here. For this node, the out degree is going to be whichever the nodes are going outside. So there is a one out degree, and there is one in degree for this node. And then degree of a node is going to be out degree plus in degree. So out is 1, in is 1. So 1 plus 1 is going to be 2. That's an degree of a node. So yeah, you can say here out degree is it is going as a number of edges that's originated from the node is going outside. And then in degree is going to be a number of nodes coming towards a node. And then degree of node is going to be summation of both in plus out. And then source. When will we call that as a source? So for example, if it have a only positive out degree, if it have only a positive out degree, then that is called source. And then when will we call it as a sink? When we have only in one when we have only in node, that is called an sink. Okay. So source means what? When we have a only positive out degree, sink means when it have only in degree, that is called sink. And then reachability is nothing but if there is a path exists between one node with another node, that is called reachability. So these are the different terminologies which we have in the graphs. Okay, so at first we have seen what is the purpose of graph and where do you use the graph in real-time scenario, and then we have seen the terminologies called vertex and edges, and then we have seen the different terminologies called an regular graph, and then a simple graph, multigraph, complete graph, and then a graph with loop, digraph. In the digraph, we have seen in degree, out degree, degree of a node, source, sink, and then reachability. So these are the different terminologies which we have in the graphs. Thank you.